If you don't want to handle errors in your own procedure, you can simply raise them back out to the caller by doing nothing at all. If you do nothing, that is, if you have no catch block, just do nothing, it'll raise itself back out to the caller. You saw examples of that. You can determine to handle some exceptions and raise others by only catching certain ones. Imagine in our previous example with all those catch blocks, if we hadn't handled the file not found exception, and if we didn't have those generalized exception handlers, the file not found exception would have gotten raised out automatically to callers. Ones you don't handle are just raised back out. If you don't handle them, somebody else has to. It's called passing the buck. If you want to pass specific errors back to your caller, that is not the one that just occurred, you may want to change it to be some other exception, or you may want to build your own exception, something that the .NET Runtime didn't know about. In that case, you use the throw keyword. You can specify the exception that you want to pass back, or you can use throw by itself to pass back the current exception. Now note that this only works when you're in a catch block, because you just caught an error and you're going to throw it back to the caller of the procedure. Now you can add a throw statement in a try block and you'll jump immediately to the most local catch block. So you can have throw either in a try block, in which case you'll jump to the local catch block, or you can use throw in a catch block by itself to throw the current exception back out to the caller. If you raise an exception, the .NET Runtime looks back up the call stack for a handler that handles this particular error. That is, if you raise it from within your own catch blocks. If you raise it from a try block, the .NET Runtime looks in the current procedure for an exception handler, and then, if it doesn't find one, looks back up the call stack. There are a number of things you can do to handle exceptions. You can do nothing at all. In that case, the exception will pop back up the call stack. You can catch specific errors and let the others bubble back up the call stack. You can handle every error, as we did in our previous example. In that case, we handled some specific errors, and we also handled just plain old exception, which means that we're handling every error that could occur. You could throw errors specifically back to the caller. You could handle some and throw others. If you throw an exception, you can create your own new exception instance, and the constructor allows you to specify a message. You can specify both the message and the inner exception, that is, the exception that caused the error. In the receiver of the exception, that is, the catch block that traps the exception, you could use the inner exception property to get at the original exception information. This only works if the code that raised the exception included that information. Let's try a demo that shows off some of these features. In our example this time, I'll try throw exception. You'll see what this is doing. Now here's the scenario. Imagine that you've written a procedure as an experienced developer here named testthrow. You're an experienced developer, so you know how exceptions work, but you're writing it for perhaps inexperienced developers who don't know how to handle multiple exceptions. Your goal in this procedure, no matter what happens, you're going to throw back a file not found exception. No matter what exception occurs, that's what you're sending back to the caller. So let's step in and watch this happen. We call testthrow, and here in testthrow we have a try block, and we're going to attempt to open our file. Well, it fails, of course. Down here we've received an exception that tells us that something went wrong. No matter what kind of exception it is, and I know any exception will end up here because I've trapped the base exception class, no matter what kind of exception it was, I'm going to throw a file not found exception. I create a new instance of the file not found exception class. I specify my own message, which is true no matter what. We were unable to open it, that's for sure. And I also pass to the constructor the exception that just occurred as the inner exception, which in this case is, let's see what kind of exception it is. It is an IO error here or something like that. In any case, we're passing that back up. Press F11, and here we are back in the original procedure where you've told beginning developers calling your test throw procedure that they should always catch a file not found exception, because that's what your code threw back. Here we'll catch the file not found exception, and the beginning developer might just look at the message property and see we were unable to open the specified file, and that's what their code would display. But a more experienced developer could check the inner exception property and find out what actually went wrong. Now I've placed this inside a try-catch block just to prove that you can nest try-catch blocks. A better solution would have been to check to make sure that inner exception wasn't null before going on. Inner exception could be null, so if you don't check, you better put it inside a try-catch block. Here we've got a try-catch block inside a catch block. Pretty cool that you can do that. Here I'll display the actual message that occurred, which was the device isn't ready. So we've used the inner exception property to determine what you placed into that exception that you threw back from your code. Notice here in the catch block, I'm doing nothing at all. If I do nothing at all, it's as if I had just code set up to disregard the exception. Now here, we caught this specific exception, so we're done. We won't end up here catching exception EX. As a matter of fact, this will never happen, because we know that test throw can only raise this one kind of exception. Will always end up in that catch block should something go wrong. That's an example of throwing your own exception back out from your procedures that you create. You might note in this example that I had two variables named EX in the same procedure. Here, we had catch this exception named EX, and down here, another exception named EX. That's no problem, because this variable is scoped to this one block, and this variable is scoped to this one block. I couldn't create another EX inside here because I have one in that same block, but here, because they're two separate blocks, we're all set. Often people use the same variable name EX for all their exceptions. You may find that you need to run code whether or not the code that did the work actually succeeded. To do that, you add a finally block after the catch blocks, and the code inside the finally block runs no matter what. Now you don't need to have both catch and finally blocks. One of them has to be there, however. Why would you ever have finally without catch? Well, that would happen if you want to allow the code that called you to handle all exceptions, but you need to run some code before you leave the procedure. In that case, you can use finally without catch. Maybe you need to close a database connection, or release some memory, or write something to a log file somewhere. You want to run some code before you leave the procedure, but pass the exceptions back out to a caller. If you don't have a catch block, those exceptions are being handled back up the call stack. Let's see some examples of working with finally and catch together. To demonstrate this, I'll test the finally block here. We'll step into this, and so we attempt to open our file. Notice I've made fs be a variable outside the try block, where it would be scoped and visible only within that block. Here, I've attempted to open it, and of course it fails. Here, we'll catch the exception and display it. But before we leave this procedure, we'll run our finally block code, which check to see if the file isn't null. It is in this case. If it wasn't null, we'd close it. Well, it was null, so we don't bother. In any case, we did hit that finally block and run the code. You're probably thinking, what happens if I have a return in here? Let's modify our procedure so it returns an int. There we go. And let's try this. Of course, it complained because not all code paths return a value. So down here, and let's see what happens. We go in here, the code fails. We display the message box. We hit the return statement, but we don't return yet. First, we go to the finally block and run this code, and then we return that 1. Now, there may be a better way to accomplish that same goal. Let's look at the using block. If your only purpose in the finally block was to close some resource or release its memory back, you may be better off using a using block instead, which does the exact same thing, just in a more concise sort of way. Here, this using block declares our file stream variable for us, and if it succeeds, great. If it doesn't, we go to our catch block, but by this point, we've already left our using block, so even if we had opened that file stream variable, we would by now have closed it. And here in our exception handler, we can just display the message, and we're guaranteed that we have the same behavior as if we had a finally block that did the same work. So if your finally block exists only to release resources, think about using a using block instead to do the work for you. You remember that ugly dialog box that appeared when we didn't handle an exception and the .NET Runtime had to handle it for us? You can get rid of that. In a Windows application, you can handle the application.threadException event. If you handle that event, your code will run in the case of an unhandled exception, and the .NET Runtime won't do it for you. You have to add the event hookup before loading your main form. In your main procedure, before application.run, you can remove and then re-add the handler as necessary, but you've got to add it before application.run. If you don't add it before application.run occurs, it'll never work. The .NET Runtime will just not see it there. So you need to put it in your main procedure before application.run, and then you can work with it as necessary by adding and removing the handler if you need to do that. Well, let's go see how this plays out in a real demonstration. To remind you what an unhandled exception looks like, let's try again with no error handling. And remember, you just get an error like this because no one handled the exception. So that's not really what we want. Now, in order for this to work, we have to hook up the exception before our application.run. Right now, our startup object is the startup procedure in exception handling. Well, where is that startup procedure? Well, it's here. In the startup class, we find a procedure called main. Now, inside here, I've commented this out. I'll add it back. I have a call to hook up an event handler for the thread exception event of the application object. Now, this event delegate must be of a particular type. It's got to be a thread exception event handler, and you can use C# standard event creation mechanisms, pressing tab as you type, to create this for you. Here's the procedure handle errors. It must accept two parameters. The first one's an object. Second one is a thread exception event args object. And in ours, I'm just going to call messagebox.show to display our message box. Now here, we're now handling the event because we've added this before application.run. When our application starts up, it's going to use this unhandled exception handler. Let me compile this whole thing and run it here. Inside the debugger, actually I don't need to go to unhandled exceptions. I can do it right here because we're handling it now. There is an unhandled exception handler. Here, within Visual Studio, of course, we still get this error, but then this dialog box appears and we don't quit. We're back where we were. If we try it from outside of Visual Studio, here, all the user sees is that message box, and they're back in business. We've handled the unhandled exception by hooking it up in the main procedure before application.run, telling the thread exception event to call this procedure and do whatever it says in the case of an unhandled exception. That is, if it bubbles all the way back out to the .NET Runtime, right before handing it off to the runtime, run this code instead, to ensure that even if no one handles this exception, this code will handle it for us. What if, in your application, selecting a file larger than, say, 100 bytes is an error? Now, there's no file is too large exception built into the .NET framework. You could add your own exception called file too large exception. You would then watch for that exception and handle it specially. You would have to have code that raised that exception. So we have 3 steps. We need to create the exception class, we need to raise the exception, and we need to catch the exception. Now, in order to create your own exception, you have to provide your own constructor in your class that inherits from application exception. You also need to add any extra functionality that you need. Well, let's go to the code and see how to create your own custom exception class. For this example, I've created a new class named FileToLargeException, which inherits from applicationException. There's a private field named FileSize here, and because I want to create my own constructor, I need to have constructors for the built-in, that call the built-in constructors for the other 2 constructors. Here I've got one that calls the base constructor passing the message, base constructor passing message and the inner exception, and here I have a third constructor which allows me to specify the 2 parameters plus my file size. Here I call the base classes constructor passing the 2 parameters and also store the file size into my private field. Later, if someone needs to retrieve that file size, they can retrieve this read-only property and get that private field's value back. Well, that's all there is to our own exception. How do we use it? Well, here in our handleException class, let's look for FileToLarge. And here's the code that's going to call a procedure named getSize. GetSize down here, given a file name, attempts to open the file, retrieve its length, and if the file size is greater than 100, well, the .NET runtime doesn't see that as an exception, but this code does. In that case, it raises the FileToLarge exception using the throw keyword, passing in the message we'd like to display. The inner exception is null, so we put nothing there. There's no reason to have an inner exception set. And the file size. We're calling the constructor that lets us store away the file size. If nothing goes wrong, we just return the file size. Back up here in the caller, we catch that FileToLarge exception and display, as you can see here, the file size property of that exception. If something else went wrong, we handle it separately. Well, let's try this. I'll try retrieving the size of AutoExec.bat on the A drive. And of course, this fails just like it's failed every time before now. We just raise a standard exception, and you'll see the message is the device isn't ready. Well, how about creating a file that is too large? Here I'll create a new text file named test.txt, and in there I'll put a bunch of text. So it's more than 100 bytes. Save it back out and run it. Hopefully it's big enough to cause an error. Here we go. Of course, I typed in the wrong file again. Let's try c:\test.txt. We come here, we call getSize, we open the file, and for the first time in this demonstration, we've actually opened the file. Let's retrieve its length. Its file size is greater than 100, good. Since it's greater than 100, we're going to create a new instance of the FileToLarge exception and throw it back to the caller, specifying the file size in the constructor. You can see here we're calling that constructor and storing the file size into the private field in the class. Okay, well here we are. We've caught that exception in the calling procedure, and we can even display now. We're retrieving that file size. We're going to display an alert that tells us the file was too big. The file you selected was 210 bytes. So even though the .NET Framework doesn't think that's an exception, we've added our own rules to this application. me make one more text file. And in that text file, I'll just put hello and save it. Go back and run our code once more using c:\small.txt. There we go. Try it one more time. Come in here. In get size, we open the file, retrieve its length. Its file size isn't greater than 100, so we just return the file size back, and everybody's happy with no exception happening. So you can see that you can easily create your own exception to trap for cases where your code handles something as an exception, but the .NET runtime doesn't have a built-in exception for that particular condition.